Ladies and gents of astronomy, it is a pleasure to reach out to you, as strange as this classroom has become. Welcome to your astronomy classroom. You're here in my laundry room. Doesn't really look like it because I'm showing you the part that's a little more interesting. All right, but we are here today for Pick a Card number 1. I've got your questions. I brought them home with me today from school in anticipation that we wouldn't see each other for a while. So let's get right to it, shall we? All right. Let's start with first period, B1. Let's see what your questions are for the day before we get on into today's lesson, which will be in a different video. Okay. I have not screened them. I am picking them at random. This is first period, B1. Let's see here. All right. I picked this one at random from B1. Here we go. Oh, this person has several questions. Let's see what's on their mind. If a black hole were to begin right outside of the Oort cloud, what would happen? Well, that would be a bad day for all of us, because unless something is in a stable orbit around a black hole, it's going to get pulled in. That's just gravity for us. Okay, let's assume that the black hole is not falling towards the sun, or that somehow our solar system is in some kind of a stable orbit. Well, at the edge of the Oort cloud, those comets would get yanked down into the black hole because they happen to be nearby. How far does the influence of the black hole's gravity reach into our solar system really depends on the size and the mass of the black hole itself. Some are relatively small, and some are, as the name suggests, supermassive, scary big, scary heavy. I would have to do a little more research to see what a average black hole, if there is such a thing, what it would do to objects such as our outer planets. I think Pluto would bite the dust. I mean, that's sad, right? First it gets demoted, and then it gets sucked into a black hole. So let's hope this doesn't ever happen. There's nothing near us in space that we know of by the way of black holes, but it's an interesting question. Next, would Earth be pulled into a black hole immediately in that example? Or would humans have a countdown until the sun disappears? Let's just say they are not in a gentle, stable orbit, this black hole, and our sun and our planets. Yeah, it would be like falling, okay? Except in space, there's no up or down. It's still like falling. Okay, so when you step off the high dive or a high platform, say you're up at Lava Hot Springs, taking a jump and going into that pool, you have a whole second to think about it before your feet smack the water and you're like, what was I thinking, right? But the first part of your step is nice and slow compared to the rest of the fall. It just accelerates faster and faster. Again, gravity is a force working continuously, causing continuous acceleration. So I think we would have a little time to think about it before it starts pulling us away from our sun. The sun would get dimmer as it recedes away as the Earth gets pulled. And then you get close enough to the black hole that Earth's atmosphere on that side would get pulled off. Then the surface things on closer to the black hole would get pulled away, and tidal forces would slowly tear the Earth apart. Scary. And yeah, let's just say that let's vote. I vote no. Let's vote that doesn't happen. Good question. B1. Excellent. Okay. B2. Let's see what your question is, B2. Here we go. Give me just a second here. Make sure I don't mix up the piles. That's good. Okay. And B2. Again, your questions. No particular order, and I have not read them. All right, B2. Let's see what's on your mind with this person's question. What is the farthest galaxy we've discovered? Yeah, this is a really amazing... The answer blows my mind, still boggles my mind. The number is north of 12 billion light years away. When the Hubble Deep Field looked at the darkest patch of sky that NASA and the research communities in those universities, the darkest part of the sky they could find. And they had Hubble look at that dark space over and over again, as it made its orbit around, it would look at the same piece of sky as it made its way around the Earth over a long period of time and gather what tiny little amount of light it could find. And it discovered thousands and thousands of galaxies, each one with billions of stars. The further away those galaxies were, the older they are, because it's taken that light from that galaxy a longer time to get to where Hubble could look and peer into the darkness and see the light coming from that distance. On a photograph, it looks like a reddish smudge. And they know it's a galaxy, an infant galaxy, maybe one of the very first galaxies in the universe to form. Very exciting stuff, but it is, in fact, 12 point some number above 12 billion light years away. And the universe is only, how old? Say the number. How old is it? Hope you got 13.8 billion years old. So higher than 12 billion years. This is a very young galaxy that formed very shortly, relatively speaking, after the universe formed. Very exciting stuff. All right, and third period. B3, here we go. Let's see what's on your mind. Okay, shuffle them up. B3, you guys come up with the really good questions because you keep adding more. I've never had a class do that before. So hats off, tip of the hat to B3. Good job, very nice. And let's see what your question is. Again, there's a lot of questions here. Let's shuffle them up really good and pick one randomly from the middle, that one right there. All right, third period. Let's see what's on your mind. Here we go. Do you think there is another object way beyond our solar system that is capable of creating or sustaining life? Absolutely yes. Absolutely, without a doubt in my mind. There's a really neat mathematical suggestion called the Drake equation. And that's where they look out and consider the sheer number of galaxies and the number of stars in those galaxies, and the number of planets that are probably on average between 2 and 6 planets going around each of those stars. My dog is putting in a suggestion here. Yes, thank you, Walter. Thank you. I'll tell them. Okay, shush. Goofy boy. I apologize for that. So the Drake equation, even if a small fraction of those planets has life, and only even a small fraction of those planets that have life that grows to self-awareness, what we would consider intelligence. Even if a small fraction of those happens to be at that point in its development right now, and they have the technology to receive signals or send signals or explore space or colonize or visit their own satellites and neighboring planets or what have you. We just narrowed it down a lot. Even with those very strict parameters in place, the number of intelligent life possibilities in the universe is staggeringly huge when you're given the volume of life in the universe. We just haven't met them yet. So we'll give it a little bit of time, okay? We just haven't met them yet. So hang on, keep listening, pay attention to the news, and we'll see what we can find out by way of possibilities out there. We've already had 2 visitors from other solar systems. One's an asteroid, they believe. One's a comet, they believe, passed through our solar system within the last couple years. So very exciting times. The more we look to the skies, the more possibilities we find, the more we learn, the more we realize we can't possibly be alone. And on that happy note, in this day and age of crazy delivering instruction from my laundry room, right? You're not alone. I am, except for that dog down the hall. But you know what? We're still in this together. Let's get through it together. Come back energized whenever we get a chance to get back in the classroom. So keep looking at the stars. Keep looking up, as Neil deGrasse Tyson is fond of saying. And have you done your homework yet? Look at the night sky. If it's a clear night tonight, do it tonight. Look at Venus towards the sunset. Pan a little bit left with your vision. Find Orion, the 3 belt stars. Look at the upper left. That's Orion's shoulder. It's Betelgeuse. and then compare that red supergiant star drop straight down in the sky below Betelgeuse and find a really, really bright star called Sirius. Compare the color of those two, Betelgeuse and Sirius, lower in the sky, and see if you can spot with your eyes the color difference between a red supergiant and a beautiful blue giant star, Sirius. That's your homework. First round of Q&A is done. We'll keep doing pick a card. I'll keep uploading new lessons. In the meantime, we're here. Remember, thoughtful, be amazing, support each other, and keep your Lancer pride about you. Bye.